So we start by going to the model result. We open the space dimension, and with this, we'll be using a 0D for our physics. We'll be using chemical species transport. So go to reaction engineering, then we add. For our study, we'll be using time-dependent study. So we go to study, time-dependent study, click done. So that will take us to the global definitions, and we go straight to our parameters where we'll actually load our parameters from far. So we choose the load from far, and we come here to select tank flow systems parameters. Okay, so now that we've added our parameters, now go to reaction engineering, and locate the reactor section. Under the reactor section, from the list, we select the constant mass generic mixture properties. We'll be using it should be liquid. The reaction. So the reaction formula would type A is equal to or greater than B. Click apply. And that is rate constant. We'll put here K. Let's call reaction. We go to species A. And under the general parameters, we'll type M, A, A, in species B. Also for the molar mass, we put M, let's call B. We'll add a solvent the first tank. So this species name, let's make it S. And also species type, we'll make it solvent. Here will be M and underscore S. For the density will be M and underscore. For the density score S. We go back to physics and reaction engineering, and we look for go to mass balance. Under the volumetric rate, we select generic. So the generic in this mass balance section will substitute the constant mass condition. Reset to default. Reset to default. Okay. Make sure everything is reset to default. It will be v underscore outlet 1. And under the initial values, where we have the initial system volume, we'll put this expression vr underscore initial underscore tank 1. We'll add one feed inlet to this first tank. We put the feed inlet. So under the feed inlet properties. Volumetric feed rate will be changed to V inlet species. You have the inlet underscore A one. It will be for the B will be in the back is 0. The inlet underscore S. After we've done this, then we want to set the solvent in the first tank initially. So go back to initial values 1. So under this table, we want to put S equals C inlet initial S. So let's go back to component 1. Then we want to model the reactor again. We want to add a second reaction engineering. So we want to add new physics. So we have the second one here. Here we choose a constant mass generic mixture properties will be liquid. Go back to reaction 1. So under reaction 1, what we'll do is that we've done this for the first reaction, reaction 2, reaction 1. We're going to do the same thing as we did this. Let's put A equal to greater than. Equal to this value. Click apply. Here will be K KF underscore reaction. And the species A. It will be N underscore A. Go to species B. Under the general parameters, also here will be M and underscore B. Add species. So this is just for the second tank. This is for the first tank. This is for the second tank. Name will be S. Apply species type will be solvent. Will be M and underscore S. Density underscore S. Go to the mass balance. For the metric rate, it's changed to generic. Reset to default. Here will be V outlet. So go to initial values 1. Initial systems volume will be set to be initial underscore and 2. Let's add a feed inlet. Yeah, I think it's to the second reactor. So that's equal to the whole outlet stream from the first reactor. Here will be named feed inlet 1 from tank 1, the first tank. So this feed inlet from tank 1. Here will be V, let's go outlet 1. And here will be concentration of reaction species A, B, C will be RE.C underscore A. Same for underscore B. Same for C, RE.C underscore B. So we're going to add a second feed inlet to the second reactor to model the first feed. So that'll be feed inlet So now that it's added feed inlet 2, this will be named fresh inlet 2, which is a fresh. It's a fresh feed. Here will be that's fresh feed 2. Here will be fresh 2 underscore A. Inlet underscore F. So you will have this in here. The next thing to do is to go back to the initial values. Okay, this is it, fresh A. So initial value is 1. Make sure that only solvent exists here. So locate the table here and we make sure we make here P initial S. So now that we are done with the physics for the reactions for tank 1, tank 2, the next step is to start with the study. So I'm going to continue that in the next video. So if you have any questions so far, please let me know and I'll see you in the next video.